Hello everyone, today is December 4th, 2025, and we're going to solve this Leetcode 235, lowest common ancestor of a binary search tree. So basically the LCA definition is like, there are like two nodes there. So for example, I think the example that Leetcode gave is like a 2 simple. So you have like 2 and A. So the common ancestor will be 6 there. So you want like a 2 nodes that have the same ancestor, but this ancestor can be itself as well. So this is another example. So like 2 and 4 are the 2 nodes. Then the common ancestor is 2, because a node can be itself ancestor. I know it's weird, but that's how the question is designed to be. And like a more typical example probably would be like 0 and 5. Then if you want to look at the common ancestor, then 2 would be the lowest common ancestor, because like 6, it's also a common ancestor of 5 and 0, but it's not the lowest. If it's like 6, there must be a higher one. So the solution for this question is actually pretty elegant, I think, coding wise there. So let's get started. So first of all, let's initialize a current variable and initialize it to be root there. And then we can have a while loop. So as long as the current is like a valid node, it's not a non-pointer, then we should continue this while loop. And then, so what's the characteristic of like the common ancestor? Basically, if there are two nodes, they are both on the left side of a node, then we know that we can go one step to the left. There must be another node that is like lower than itself there. So this is not a common ancestor. And if similarly, if both like a node P and Q, they are on the right side of a particular node, then we know that there must be an LCA on the right side, then that's lower than the current ancestor. So apparently like root is an ancestor of like every other single node there. But basically we're just going to keep iterate this process. If there's something we know that it must be on the left, then we go to the left. If we know it must be on the right, then we just keep going to the right until at what point basically there should be like a one node at the left and one node on the right side of like a particular node. So for example, like 0 and 5 case, then one of them is on the left and one of them is on the right there. So we know that like it cannot go either way. If it goes this way, then it's not an ancestor of 5 anymore. If it goes to the right, then it's not an ancestor of 0 anymore. So that the condition basically like one node has to be on the left and one node has to be right, and the exception is like the node equal to itself. But if both nodes are on the same side, then we know that it has to go left or go right. So now let's implement that. So first of all, like if current value is larger than like a p dot value, and current value is also larger than q dot value, then we know that like we should go to the left, right? So because like the current is too big, then we need to lower it. Everything is on the left side. So let's make current go to its left. And then else if current.val is smaller than p.val and current.val is less than q.val, then we know that it's too small, that we should go to the right. So set current to its right. And then the final case is like it cannot go anywhere. It cannot go to the left. It cannot go to the right because that will violate the definition of ancestor. So itself must be the lowest ancestor of the two nodes there. So we can just return current. And now let's try to run the test. The small test, it passes. And the big test also passes there. So yeah, the solution itself is pretty simple, just a few lines of code, but like coding wise, it's not very easy to represent like the common ancestor. There are too many conditions. Like you need to write like one on the left, one on the right, and itself can also equal to be its own ancestor is not very easy to express. So the way we write that is basically there are like two conditions that we can write the negate of the condition. Basically, we know this is not, then we move forward. We know this is another case that is not an LCA, we move forward. And the remaining cases, it must be the LCA. So that concludes our solution. If you found this video helpful, please smash the like button. It really helps support the channel. And don't forget to subscribe for more content like this. Subscribing also helps the algorithm recommend similar videos to you. Thanks for watching, and I'll see you in the next one.